Okay, good afternoon, class. So today we're looking at Euclidean geometry. We spoke about some Euclidean geometry rules there and theorems, and we spoke about the properties of a cyclic quad. We also spoke about your circle geometry theorems there, your parallel lines, and so on. Okay. Then we went on to, in the investigation 1, we investigated that if lines are parallel, then the parallel lines will divide the sides in proportion. Not so? Then we also spoke about the multiplication, the rules of ratios, the cross multiplication techniques. Remember when we swapped it around and cross multiplied and all of those things? We came across those sums there as well. Alright, so at this point we're looking at, I can delete this one. We're looking at theorem 1. The link to this proof will be found in the description box below. Okay? As you know, it's going to be load shedding in the next 10 minutes, so we need to just get through these examples. Okay? So example 1 is on page. It's on page. This one, 248. So as soon as the letter go out, I will do the proof on the board here. Okay. So okay. So this is example 1 on page 248. This is for exercise 1. This is grade 11 SS, which means to say it's the shortened version or the examples only. This is Euclidean Geometry. Oh, you're 12 now, sorry man. Grade 12 geometry. And this is examples for exercise 1, page 251. The examples to the exercise on page 251, although the okay, so just look at this here quickly. So we did the investigation and we discovered that if lines are parallel, it will divide the sides in proportion. So what they came up with is that BC, so in triangle B, D, F. Okay, I'm trying to rush here, but I'm messing up. Okay, in that triangle, you see that these two lines are parallel. Can you all see that, people? So what can we conclude? That BC over CD is equal to FE over ED. Can you see that? And all these variations are can be applied there. Okay. Let's look at with the cross multiplication there. In triangle BDF, which is the same triangle there, we know that we are given that BD over CD is equal to, now without now looking at this here, is going to be FD over DE or ED. Can you see that, people? Let's look at the other triangle. We're looking at triangle ADG. Okay. We can say that, so they looked at AB. So they're using these lines that are parallel. Okay. So AB over BD is equal to FG. Whoops, not the double length. FG over GD. Can you see that, people? But here what is given is given in the form of a ratio. So what we can say from here is that AB is to BD as FG is to GD. for FD. So let's do that one again. So this is now for C. They said AB. Those lines are parallel and these are triangle. No? So you say AB over BD is equal to if G over if D. If G over if D. Is that correct? And that ratio can, this fraction, so this ratio can be written in another form as AB is to BD as if G is to if D. Okay, you guys understand? Alternatively, you could have looked at another one. In D, they're looking at triangle A, D, G. Again, they use those lines that are parallel by the looks of it. So AD over BD to this length. So A, B over BD is equal to AB, AB, AD. Okay. AD over BD, it would be GD over FD. You all agree with that? And another way that could be written is AD is to BD as GD is to FD. Now many of you can just look at the diagram and go straight to that. Not so. You don't have to write it in fraction form. Okay? But I always tend to write it in fraction form first before I write it in this ratio form, in this type of ratio. As we know, fractions are also ratios, not so. But you'll always see me writing it like this first for some reason. It's easier to understand. Okay. But again, if you can do it without that, it's fine. Okay. Let's go to example 2. And example 2 is on page. Sorry? Same page. Okay. So example 2 is on page 248. Okay. Any problems there? Nelly, why are you talking so loud? Okay. So example 2 on page 248, we are told that in triangle ABC, DE is parallel to BC. Then we are told that AB, the length of AB. Okay, so before I go anywhere else, what can we conclude from here? What can be concluded from there? Those lines are parallel. We know that AD over DB is equal to AE over EC, and all is multiplication rules. We also know that AD over AB is equal to AE over AC, and all its variations from. You guys understand? No? Just by saying those lines are parallel. So depending on what is given and what is needed, that is how I determine which ratio to go with. You guys understand? Right, so carry on the reading. We are told that AB is 28 millimeters. Okay. Then importantly here we are told that AE over EC is the same as 4 over 3. Okay. Again, you don't have to write it like that. I just prefer writing it. Okay. So what we do is we introduce a K substitution. Okay. Because AE is not 4 and that's not 3. It could be 4 and 3. But it could also be 400 and 300. It could also be 12 and 9. Could be 40 and 30. You guys understand? So this is a ratio. As we know, when we dealt with ratios in grade 9, we said this, no SI unit here. That is why it doesn't say meters, millimeters, kilometers. It doesn't give you a length. You guys understand? So that is a simplified version of this. So what we do is we introduce a KD. Okay? So if it was 12 and 9, then K would have been 4. If it was 400 over 300, then K would have been 100. If it was 40 and 30, K would have been 10. You guys understand? That is why we now bring in a variable here. So instead of saying 4 and 3, I say 4K and 3K. So what is the length of AC? 7K if needed. Do I need to introduce the K here? No. Not as we do in paper 1. Okay? Where they say let K equals 2 to the X. No? Yeah, we don't have to do it here. Okay? If you do it, you won't be given extra marks, neither will you be penalized if you leave it out. Okay? Then we are told, the question says, calculate the length of dB, which is this length here. Okay, what's wrong, Michael? You okay? Right, so we would like to try this one. Firstly, we would have to use dB. Why? So I need to calculate dB. So what do I say? dB over. Do you think I'm going to go with dA? No, why not? We don't know what dA is. Not so. But we know what AD is. Not so. So AB. So dB over AB is equal to, so I must go the same side here, which is EC over AC. And what is our reason here? When we use this theorem, we say it's the proportionality theorem, and we state the lines that are parallel, which is DE is parallel to BC. Okay. So let's go. We now say that what is the length of
Good
the
afternoon. Apologies for the interruption. The lights are going to go out now, so I need to do this now.
So that will give you.
First of all athletes.
Okay. CE is 3K over AC, which is 7K. Right, so what do I do now?
Sorry,
Plus multiply.
apologies.
That goes up.
All athletes who have not collected their original identity documents or the letter that they need for green card are to see me in the hall directly after school. Then, secondly, it has been decided that Solsusi will not be sending any learner support to Greenpoint Stadium on Monday. Monday will be a normal day of school for everyone except the athletes.
Alright, you guys understand? You guys understand? Alright, let's squeeze in the next one before the buildings. Please settle down. Right, let's look at example 3. If the electricity goes out before we complete the sum, I will redo it in the next video the next time I see you guys. Okay. So let's look at this one quickly. This is example 3 on page. Example 3 on page 249. Okay, so here we are told that D and E are points on the sides of AB. So D is a point on the sides of AB and BC. And BC respectively, which means to say in that order, of triangle ABC, such that AD, so we got AD over dB the same as 2 over 3. So what do I do here? I introduce a k. There's going to go a k and a k, which means to say AD, which is this here, which is 2k, BD, which is 3k. So what's the length of AB? 5k. Okay, you guys understand? So that's that. Then we are told that BE is 4 over 3 of EC. So again, I try and get it in a ratio form. Okay? So how do I get that? In fraction form, I divide both sides by EC. So that cancels. So BE over EC is equal to 4 over 3. Can you see that, people? So now if you look at CE is this here, and EC is that. So BE, sorry, and EC. But do you think I will put a K here again? No, why not? Because we already used K in the sum. Can you see that, people? Because it would represent the same variable value, the unknown value. That is why I need to change the value. So what I choose from here is then A or B or C, whatever. So from here you'll see we always use the first variable to be K. After that I use A, B, C. Okay? If you want to use a P whatever with D, it's fine. Okay? So this here, in other words, BE is going to be 4A and CE is going to be 3A. Okay, you guys understand? Take that up. Then we are respectively, such that, right? Then we are told that DK is parallel to AE. DK is parallel to AE. So if those lines are parallel, we know that that over that is equal to that over that, and so on and so on. You guys understand? Also, we are told that AE and CD intersect at P, which is this point here. Find the ratio of CP, so that's what we need, and PD. Can you see that, people? So if you look at the lines in which parallel lines that lies between, then it's lying between PE and DK, those parallel lines. Not so. So what can we say from here? We know that CP over PD is equal to, what's that equal to? CE over KE. Not so. So do it again. You understand? Okay? So, in pursuit of calculating that ratio, what are we shorting? We're shorting the length of KE first. Not so. If we have KE in terms of A, I've done the job. Not so. So let's go find KE first. So now we must see a triangle where KE is involved in. Okay? So KE, let's just change the color here. We know that KE over, this is in triangle. I need KE. I'm working this triangle. Okay, so it's in triangle ABE. We're going to say KE over, are we going to go KB or CB? KE, which is this here, yes, that's what I want to calculate, over why BE and not BK? Because I have this length here of 4A. Can you see that? Because if you have, sorry? BE, this was an E. Okay. So KE over BE is equal to? Is equal to AD over ABS. Why? The video just cut out. We didn't. Okay, so it's going to be AD over AB. Why? Because of the proportionality theorem with DK being parallel to EA. Okay, so now we know that KE is what I'm calculating over 4A is equal to AD, which is 2K, over 5K. The K's of course cancel, cross multiply that. So KE would be 2 over 5 times 4, which is 8 over 5, 8. Okay, so that is going to be 8 over 5, 8. Okay. Now we go and say, okay, as you can see, I need the space. So now we can answer the question. What is CP over PD? We'll say that CP over PD is equal to CE over KE. Why? Because of the proportionality theorem. Where the board is jumping around again. With PE being parallel to DK. So CP over PD is equal to CE. What's the rate of CE? 3A over KE, which is 8 over 5, 8. Of course, the A's cancel. Now we put that in the calculator. Whoops. We put this in the calculator. 3 divided by 8 over 5. Simply gives us 15 over 8. Okay, do you guys understand? Is that correct? Let's check there. So then you can conclude. Remember, if the question is in that form, I must write it in that form. So therefore, CP is to PD as 15 is to. Okay, do you guys understand? Alright. There's example 4. I'm just going to. The electric will go off during this time. Okay, so they just wait off. Okay. So example 4 I'm going to do on the board on that side. I will do this again in my free time and just label it as part 2 of this lesson 1. Okay.